etc. And Uranus it was. And it wasn't until 1986 with the flyby that we really got the first detailed views of it. As I said, there was evidence from a few years earlier, about a decade earlier, that ring systems have been detected because it's edge on. And that's the other really interesting thing about Uranus, is that it's tilted on its side. It kind of rolls its way around the solar system rather than traditional planetary motions, etc. It really is a very, very unique world, and surrounded by unique moons as well, all named after Shakespeare's Midsummer Night's Dream character plays, which is another interesting little fact. The thing with the flyby is it only saw briefly some of the parts of the moon, so there's some really interesting observations that are still going to be undertaken from that. But this mission isn't going to just fly by. It's going to be a full orbiter and descent probe going into Uranus's atmosphere and basically sampling what the heck is going on in Uranus's atmosphere. Hopefully on the back of that, there's going to be an awful lot of really interesting science in terms of planetary formation, the origins of our solar system. We're going to get a lot more detail from the moons. They may even find more interesting evidence, like they have done with another one of the missions that's been down selected, we'll talk about in a minute, of subsurface water. Now, the other mission that is really exciting for a lot of the planetary science community is a proposed orbiter lander, or the orbit lander, which is going to Enceladus, which is one of Saturn's moons. Now, Enceladus is really, really unique in that water has been detected, not only subsurface, which is one of the predictions with Europa, etc., and a few other moons in the solar system, but is jetting out of Enceladus. And this was detected initially by the Cassini spacecraft, and the Cassini spacecraft didn't really have the scientific instrumentation to truly analyze what was going on there. They found organic compounds in the water from some of the fly-throughs that the Cassini mission was able to do, micro rocks, all sorts of interesting stuff. But what they're now aiming to do is a combination of orbiter, where they basically are able to really sample what's going on with this subsurface ocean that's gushing out of Enceladus through the tiger stripes, but also then potentially land on the surface. Now, people have said about going to Europa and using atomic powered drills to drill through what is potentially tens or even more kilometers of literally steel hard ice. So incredibly complex, probably not going to be happening in the next few years. Whereas with this, they get the subsurface ocean for free because they're flying through it. And I think this is, again, a remarkable mission, and it complements what we already have with things like the Europa Clipper mission, which is due for launch in 2024. Obviously, we've got the Mars sample return missions, which has had a bit of a hiccup, obviously, with what's happening with the Ukraine and the cancellation or suspension for now of the European ExoMars Rosalind Franklin mission. So that mission's kind of had to be restructured. We talked about that on the previous show, but there's a lot going on, and potentially also a helicopter going to Titan, which is another thing that I kind of got involved a little bit in some of the analysis with my company with the Kraken, Titan Kraken mission, which was their submarine. My company does a lot of work with submarines. We sent some information over to the PI on that. Didn't really hear anything back, but hey ho, proving that what they designed wasn't really going to work that well. But the helicopter, obviously, with the incredible success of the Mars helicopter missions and Titan having a much denser atmosphere, the potential for a helicopter mission to Titan again is really, really interesting. So I don't know what your thoughts are on this, Terry, but I just thought the whole thing is 800 pages of this as well, this Decadal Survey. I don't know what you've got in terms of thoughts on that.
Yeah, I mean, Uranus is, at first sight, incredibly boring as a planet. It's just got an almost perfectly circular orbit. It's right in the plane of the solar system, so its orbital inclination is near enough to zero. Okay, it has some very thin rings, and it has some moons going around it, and nothing really particularly remarkable, except for the fact that it's tilted over at an angle of 98 degrees. And what sort of an event could tilt an object the size of Uranus, what is about 16 times the mass of the Earth, roughly, over by that amount? We're assuming that, like all the planets, they condensed out of the primordial protoplanetary disk that surrounded the sun, and almost all of them rotate more or less in the same direction that they orbit around the sun. Some of them are a bit more tilted than others. Earth, for example, is about 23.5 degrees, and we're fairly sure we know what happened with that, with the formation of the moon. But to knock something the size of Uranus over by an angle of more than 90 degrees is just almost incomprehensible. The other thing is that the moons, and there's what, about 20 or 30 of them, 4 or 5 big ones, as you say, named after Shakespearean characters. 4 of them are about the 1,000 to 1,500 kilometer diameter, another one about 500 kilometer roughly. Others are all small, maybe captured asteroids or comet nuclei. But they all orbit in the plane of the planet's equator. So they also are going around, as you say, rolling around the solar system. And incidentally, actually, it's interesting that the North Pole of Uranus is tilting more or less towards the Earth at the moment. I think in 2030, the North Pole will be at its closest in terms of pointing towards Earth. So the whole system, including those major moons, has turned over by an angle of over 90 degrees. Now, it must have taken something absolutely massive with a very inclined angle impact to do that. Whether they'll be able to find out by this much closer study any more information about that, I don't know, but that certainly would be one of the other things. And the other fascinating thing about Uranus is that an awful lot of exoplanets that we're discovering are in the same sort of category as Uranus in terms of size and mass. So the more we can find out about Uranus, Neptune to a certain extent, the more information that gives us in studying all these exoplanets that are similar in mass. Usually they're a lot closer in than Uranus, but that's a different issue altogether because planets can migrate in and out in terms of distance from the star. And the other fascinating thing about Uranus, it seems to have practically no internal heat, unlike Neptune, for example, which is even further out. Uranus doesn't emit any more heat than it receives from the sun, whereas Neptune does. So a number of absolutely fascinating things about it. But if you look at it through a telescope, really, it's one of the most boring things you can look at in terms of the planets. But when you get up close, it will certainly be fascinating. So I think it's a good choice.
It is, and it's really interesting as well, you say about observing through a telescope, because its magnitude does dip up to kind of the outer limits of just naked eye observation.
Yeah.
So potentially it could have been seen naked eye. And there's all sorts of talk about Galileo potentially seeing it hundreds of years before Herschel, etc., etc. So we've got this Uranus mission. Again, Terry, I completely agree. It is potentially fascinating as to, if we can learn what caused that axial tilt. It's interesting as well, question from Chris in the chat, why is it 98 degrees, not 82 degrees? It's down to orbital inclination and basically the way that the orbits work around the sun. And that's how it's measured. And it's one of those nomenclatures that it's kind of stuck with. There's probably a better explanation than that. I'd need to Google it if I was to find out, but that, as far as I know, is the reason why. So cheers for that one, Chris. Going back to the Enceladus one, the interesting thing about Enceladus, you hinted at that with the size of the moons with Uranus. Enceladus itself is only about the size of the UK. It's a relatively small moon, so its gravitational pull is so low that this orbit lander concept is actually possible. Moons that are significantly larger or that have got dense atmospheres, etc. You're looking at a whole of the ball game in terms of landing, approach, ascent, entry, descent, and landing. But with this one, they can effectively just glide down to the surface. From all accounts, it's not going to be easy, but that as another one of the flagship missions, if they can get the 2 flagship missions, one to Uranus, one to Enceladus, that'll be amazing. Then you've got these, as I said, these so-called New Frontier missions, which is kind of the second tier down. And with that, you've got things like a Ceres sample return missions, obviously. Excuse me. We've had a lot of sample return missions. We've got obviously one planned for Mars. We've had several asteroid and even cometary sample return missions that have been very successful. Ceres is another interesting one in that it's one of the larger asteroids in the solar system. And again, it's going to give us more information on the formation of the solar system. One of the things that was really depressing / interesting from this today is that we talk about the value of this is a $4 billion mission, for example, to Uranus. The total decadal mission suite, as it were, if it all kind of happens, will come in at around about $40 billion to $44 billion, which is less than Elon Musk has just paid for a website. And that is quite an interesting, I think, statistic. I don't know what your thoughts on that are, Terry, but I just find it depressing.
I'm just thinking about you and your friend Elon. Now on Twitter, you'll be able to say anything you like about him, but only on Twitter, because he's going to uncensor it totally.
Well, that's the thing. It's
don't say it on this, bro.
Is he going to really be that happy with people slating Starlink, etc.? One of my work colleagues got Starlink this week, and I've said to him he's dead to me. I'm not talking to him anymore. But yeah, he lives out in the countryside. He's getting extremely good bandwidth. Anyway, so the Decadal Survey, it is only advisory. There is a midterm kind of review of this as well, which could happen. Now, the midterm review is generally to see, okay, is it still on track? Has anything major happened? One of the interesting quotes I was listening to today was, if there was a signal from Proxima Centauri that indicated life, or if they found a fossil on Mars, or what would happen? Yes, things can change. And this is the thing, this Uranus mission isn't new. This was proposed, in 2011, the ascent of the last Decadal Survey. So things can change, but as it stands right now, these are the ones that are kind of topping the charts, as it were. You can go through the whole paper. As I said, it's about 800 pages. There's so many different people who've worked on this for years and years and years. It's not something that's kind of just quickly thrown and put together. This is really considered, very detailed study that takes into account all sorts of risk factors, the viable technology. But even if these missions do go ahead, we're not looking at probably approaching some of these. You think Uranus, Voyager 2 got there in 1986 and it took off in 1987. Yes, it did that because of the planetary alignment at the time. Now it's going to take about 13 years, even with the state-of-the-art technology that we've got now, even if it was to launch on a Falcon Heavy, get a really high level of kind of an orbital boost and a high delta V when it goes on its trans-Uranus injection from the Earth, it's still going to take potentially up to 13 years. So hence a Neptune mission would have been really out of the question, because most of the scientists working on it would probably not even be alive by the time it got there. So you've got to factor in all sorts of things like that. But even with some of these missions, you're looking at 2029 to 2050. By the time you've done your feasibility studies, you've done your analysis, you've done some of your initial research and development, and then to get them kind of ready for launch, etc., we're not looking until the best part of the end of this decade, and then some of the missions not actually getting there till 2050. So I'm hoping to still be around by then. To return to Uranus would be amazing. Let's see what happens, but it is really interesting. The other one, just finally on Enceladus, if you look at Saturn, obviously with a telescope you can see the rings. Cassini famously saw his division back in the early 1600s. One of the rings that orbits Saturn, the E-ring, is basically the water vapor from Enceladus, and the water vapor and ice crystals from Enceladus. So it is interesting. It's really interesting. The other one, just before we go on to the next story, is OSIRIS-REx. So OSIRIS-REx obviously has done a fantastic job with sample return. Apparently that's now going to be retasked as well to become OSIRIS-APEX. So after it's kind of brought the samples back, it's going to be going on to the asteroid Apophis, which is one of these potentially hazardous asteroids that, for a short period of time, there was all sorts of discussion about the risk and the Torino scale and, its potential collision with the Earth. And you only have to watch, if any of your friends around the world, watch BBC America, or people in the UK have seen the BBC. There was a really good documentary with David Attenborough called basically The Day the Dinosaurs Died, and it was about really interesting paleontological finds at a site called Tanis in South Dakota, but it did discuss the asteroid impact and size and etc. And it's really interesting now to look at these potentially threatening objects, especially in light of what's happening up in low Earth orbit and everyone seeming to chuck thousands more satellites up there. So the quicker we can get that one analysed, the better. Anyway, there we go. On to our next story, Terry. This is a good one.
Just one final point on that. Of course, this isn't just going to be a flyby of Uranus. It has to slow down when it gets there and get into orbit around it. So that means carrying extra fuel for that. So it is a much more difficult thing than just the Voyager type flyby. Yeah. On to our next one. There's so much happening now in so many different spheres. In space. It used to be just the two major players of America, NASA, versus the Soviet Union. Then ESA came along, and then a whole lot of other countries have joined in. ESA, NASA, and China, I suppose, are still the major ones. You also have India and Japan, Canada, a whole lot of smaller nations, the United Arab Emirates, and so on. But the three really big ones, I think it's fair to say, are China and ESA and NASA. And China are really steaming ahead now in all sorts of ways. They have their space station, they've launched landers on the moon, the far side of the moon, and so on. And their latest one is that they're joining in on the planetary defense angle, i.e. protecting Earth in one way or another from a possible asteroid impact, which is something we have discussed many, many times. And I'll mention one of the other ones just sort of as a background to this. So the National Space Admin has put forward a serious proposal. It hasn't got absolute final approval yet, but it's expected that it wouldn't have been published unless it is going to get the go-ahead. Wu Hanyua, I hope that's the right pronunciation, the Deputy Director of the Chinese National Space Administration, has announced this, and it's going to basically be two components: developing an early warning system, which is a bit like what we already have from NASA and ESA in terms of detecting asteroids that could be possible impactors of the Earth. And the other angle, the one I want to talk a bit about, is deflecting them. In other words, if we do find a dangerous asteroid heading for Earth, how do we stop that happening? Now, if it's 5 kilometers in diameter, we can just say, good night, it was nice knowing you. Between sort of 100 kilometers up to half a kilometer, there's a reasonable chance, if you know about it early enough, to either deflect it or break it up or something. And we already know about this. NASA already has a mission on its way. The DART, the Double Asteroid Redirection Test Mission, which is going to target a little moon, a satellite of a larger moon, Dimorphos, which is a little moonlet, if you like, of the asteroid Didymos. And I think it's September the 26th of this year, it is due to impact on that asteroid. And then Hera, a follow-up mission, will study the effects of that. Did it break up? Were bits chipped off it? Was the orbit significantly altered, which is the objective? So that will be a very small object indeed, but what we're hoping to learn is basically how the system works. If you smash an impactor into a body in orbit out there in space, is it going to deflect it to a sufficient degree to make it miss the Earth if it had been originally going to hit us? So that's what China is planning to do. They haven't announced yet what asteroid they will choose. There are plenty of them out there. It'll be one of the near-Earth objects, in other words, one of the ones that does come quite close to the Earth on some of its passes. And they're also going to be running simulations from what we know about basically asteroid structure, composition, density, whatever. What happens if you hit it? Will you break it up into 3 or 4 smaller pieces, say each one of which might be dangerous, and then because there's 4 of them, you can't sort of knock all of them out of the way, or will it shatter it into a million tiny pieces, which would be relatively harmless? So there's an awful lot that we don't know. Asteroids differ considerably in their density and their composition. Some of them may be just rubble piles or rock piles. Other bigger ones are fairly solid. Ones like Psyche, for example, are almost solid metal as far as we know. So this is China entering into I was going to say the game. It's not a game. It's a very serious subject. You could say, well, why not cooperate with ESA and NASA? That brings us into geopolitics, which is something I'm not going to delve into at the moment. But there's another way of looking at it, and that is the more different techniques and different solutions that we have for a possible impactor, the better. For example, if NASA launches something towards an impactor heading our way, and what they do doesn't work, then it's good to have another string to your bow and try something else, provided you can do it in time. So it just shows that China, another major player now in the space, not the space race, but space development in terms of what we're doing and what we're trying to do and what we can try and stop in terms of saving the Earth. They are now in on this on a very serious matter. And I think the more we have on that, the better. And I'm sure you would have thoughts on that too, Nick.
Absolutely. I mean, you've hit the nail on the head in that you only have to look at meteorites, for example, or asteroids, as you said, in general. You've got between your rubble files, which is what they believe hit Tunguska in 1908. You've got cometary bodies, which is a whole other ball game. Then you've got your nickel iron, really dense nickel iron, pure iron style asteroids. Then you've got your stony irons, where you've got your palisite groups, etc. in there. Then you've got asteroids that could have significant fractures. You only have to look at some of the cometary bodies that have been approached of recent years. A lot of them have that kind of classic Kentucky Fried Chicken peanut drumstick kind of shape, where you've got a bilobal kind of body with a very thin kind of intersection neck, where rotation of the asteroid is dragging the rubbly material out towards the edges. It's going to be really interesting, because when it comes down to the real thing coming our way, and they've really got a planet, you're not going to have the luxury of being able to study the asteroid in any kind of great detail. You're not going to be able to go into orbit around it potentially. You're going to be looking at a singular strike kinetic impact, depending on the size of it. And as you said, you go from 100 meters, even a 50-meter wide asteroid, you only have to look at Barringer Crater in Arizona to see what a 50-meter wide asteroid can do. So from 50 meters wide up to, a kilometer or two, you're looking at city / nation state killers, as it were, in terms of, something 5 to 10 kilometers wide. As you said, it's almost game over. You only have to look at what happened at the Cretaceous Tertiary boundary 66 million years ago. That was that kind of size. In the 100 to kind of 300 meter class, being able to categorize and look at different mitigation strategies based upon the type of asteroid or comet, I think is going to be where the real gains are. And the more countries that get involved in this, if China, if Russia eventually, come back into the play, as it were, as a major space player, China, Russia, European Space Agency, the Japanese Space Agency, Indian Space Agency, United States, this should be a primary focus, because it's going to be one of those things that when it does happen, we need to be prepared. If we're not prepared, we have no option. Thankfully now NASA have large enough launch vehicles with Artemis SLS, and obviously SpaceX with Starship and the Falcon Heavies. We've got back to a time where potentially, if something large is coming our way, we've got something large to send up, as it were, to either carry warheads, whatever, eventual strategy takes place to deal with this. But I completely agree with you. The more, the merrier. And it's great to see China doing, again, great science. This is the thing. If they focus, purely on doing great science, they really are knocking it out of the park all the time. So let's hope that this is a very successful plan, very successful mission for them. Obviously, they've got concerns based upon low Earth orbit debris with, their own space station now. They're having to do maneuvers to dodge out of the way of some of the orbiting debris. So they're clearly thinking, well, it goes from the small scale, from a tiny little piece of debris, which could harm an astronaut or a space station, through to, as you said, something that could potentially wipe out all life on Earth. So huge hat tip to the Chinese on that one. Going to a question we've got from Jamie in the chat. Do we think Twitter will go behind a paywall? Who knows? What the mind of Musk is the mind of Musk. I mean, he's the richest man on the planet. He doesn't need the money. So putting it behind a paywall, who knows? He's really into the whole freedom of speech thing, and that's good. If it does pan out that way, that he allows, really good open discourse, that it doesn't turn nasty, that it doesn't allow people to have nasty or, horrible views kind of openly back on the platform. That's what we all hope, I think, with that. And on that one, let's move on to our next story, which is Artemis. So they've had another mishap. This thing, I mean, you can say it's all part of the testing regime. And yes, I'm a test engineer by trade. Test often, test early, make sure that you iron out all the kinks as much as you possibly can is the mantra. And I think NASA are doing a good job in that respect. They are not taking any chances with this. So they've had 2 attempts at a wet dress rehearsal, which is basically taking out on the pad on the crawler transporter. Crawler transporter built during the Apollo era to move to Saturn V's. So this is, you look at the rocket in the picture, that is almost the scale of a Saturn V. So we're talking about a significant rocket here. Taking it out, basically putting it on pad 39B. Now, pad 39B's really interesting history. That was first launched to launch Apollo 10, and that was the only Apollo mission that ever launched. So 39A took all of the other Apollo missions. Apollo 10 was the only one from 39B. Then they went on to Skylab. Some of the Skylab missions were launched from 39B, but they weren't Saturn V's. They were Saturn 1B's, apart from the initial launch vehicle, which was again on 39A. So it's got an interesting history. 39B's interesting history kind of carries forward to the space shuttle as well, in that the space shuttle, all the missions up to, and this is again quite an unfortunate kind of segue, up to 51L, which was Challenger, were launched from 39A. 39B was the first time it was used for the space shuttle, and that was the Challenger tragedy in 1986. So it's got an interesting history anyway. 2 attempts, they've had issues with the helium valve. couldn't resolve it. It's now been taken back into the VAB. Now the VAB, if you don't know, the Vehicle Assembly Building, again from the Apollo era, basically designed for the development and build of the Saturn V, is the tallest human-made single-story structure in the world. By single-story, the doors on this thing, I think, are around about 390 feet high, so just about large enough to take the Saturn V in its full configuration, which is 383 feet at the time. So maybe a little bit bigger than that, but essentially the doors are huge. They're absolutely enormous doors, and there's all sorts of stories about it having its own atmosphere, etc. But it's an enormous structure. And unfortunately, Artemis, and this is companies like Jacobs who are working on this, and obviously Boeing, etc. They've had all sorts of issues with hydrogen leaks on the mobile launcher, unreliable gaseous nitrogen servicing, and it's all sorts of things that effectively said, right, we're going to have to pull the plug on this and we're going to have to move it back into the VAB. It's good that they are taking this very seriously, that they have delayed the launch again. You know, you look at the approach taken by NASA on this versus the approach taken by SpaceX, which is fail fast and very much more in software analogy terms, the agile methodology, where you fail fast and try again and keep failing and trying again and keep failing and trying again. With this mission, obviously, it's very expensive. If they fail, you know, we're talking about potentially hundreds of millions to billions of dollars on a failure on this, unlike, you know, Starship, which is considerably less costly. So I'd say this is a good thing. I think NASA have taken the right decision. I think it's unfortunate, again, that the prime contractors behind this are having so many issues, but hopefully we will get to see an orbital mission around the moon uncrewed within the next year or so. Obviously, the 2024 plan, which was all hype and kind of a bit of PR more than anything, isn't going to happen. Hopefully, by 2027, 28, we're going to see the first humans back on the surface of the moon since December 1972. No risks there. I don't know what your thoughts on this are, Terry, but I think they've done the right thing.
Yeah, absolutely. I mean, you don't take chances with that amount of expensive hardware. If it blows up, for example, it's not only the loss of the rocket itself, but you do a tremendous amount of destruction to the launch tower and so on. You just can't risk it. You have to play safe. Incidentally, you can watch the rollback live on various channels from NASA Live. I think it's due to start at 9:30 this evening. Now, it may take quite a while. It's a pretty complicated procedure, as you can imagine. The size of not just the rocket, but the crawler that it's mounted on is just mind-boggling. And the building itself, as you say, if you get a tour around there, you'll go on a bus. And as you approach the building, you know, it's way, way in the distance, but still looks pretty big. And you'll see a little coloured patch up in I think it's the top left corner, might be top right, the the American flag. And you get closer, you can see the detail of the stars and the stripes. And when you get a bit closer, the driver tells you, you can drive this bus up along the stripes on that tiny little flag. And it's a huge flag, obviously, but it looks tiny in comparison to the rest of the building. It is just mind-boggling size. So that would be worth watching. You'll see the size of the people walking alongside the crawler. It just gives you some idea of the scale of this. Yeah, but you're absolutely right. They can't take a chance. They have to get everything working properly before they try and fuel it up again.
Yeah, if you've not seen the film Apollo 11, well worth watching. I think it's on one of the streaming services, maybe Netflix or Amazon Prime. But if you've not seen it, watch it. It's an incredible kind of reworking using some 70mm footage from the Apollo era that the director basically managed to compile together, and Stephen Slater, good friend, worked on a lot of the audio design for that movie. Really, really remarkable film if you've not seen it. And the opening sequence for that is somebody walking in front of the crawler transporter. Yeah. And this thing's only moving at about 2 miles an hour. Can't move much faster, obviously, because they don't want to topple the rocket over. But up until recently, I think it's been surpassed by something in the mining industry. But again, up until recently, this was the largest vehicle on the planet. Mm-hmm. So they built the largest single-story building on the planet to build the Saturn V. They built the largest vehicle on the planet to move the thing. So, and it's still, up until this point, you know, obviously SpaceX have had their full stack kind of test, as it were, or rollout of the Starship. But in terms of getting something off the surface of the Earth, until the SLS launches, and even when the SLS launches, the first stack isn't going to be as big as the Saturn V. So we are waiting for SpaceX to launch Starship. 50 years on, still the largest thing ever to lift off the surface of the Earth. I mean, it's essentially like launching a battleship into space. That's the analogy. Anyway, it's just going into the chat here. The mobile launch now $500,000 from. Yeah, I know it's amazing. The cost of this, and we've talked about this, and I've had quite heated debates with some of the contractors involved in this. I mean, some of the cost estimates are in the billions for the launch, and you only have to look at what obviously Musk is doing with Starship and Falcon Heavy and the cost efficiencies and savings, and then we've got New Glenn coming from Blue Origin, etc. The whole model really is going to change. But don't forget, this is again a NASA project, and it's been in design and development for so long. It's there now. They can't just cut the umbilical, as it were, and let it go. They've got to see this through. But I think this is probably the last of the great mighty NASA rockets, as it were. We're probably going to see companies like SpaceX, Blue Origin, etc., working for the delivery of even the deep space missions, as you said before, the Enceladus mission. Potentially you could be looking at Falcon Heavy launching that. Europa Clipper is looking like it's a Falcon Heavy that's going to be launching it. So, it is really interesting. But Chris is saying it's not working correctly. It's 60 years old. I mean, how many cars that are 60 years old still work? So, and you're lifting something that's in the 3,000 ton kind of region. So, yeah, it's an interesting one. I've just had to move the microphone. Sorry if I was popping a little bit before. But anyway, moving on to our next story.
Yep, this is one that I came up with. The most important object in the whole universe, as far as we're concerned, apart from the planet where we live on, is our own sun. Perfectly average star, we're always told. But even though it's by far the closest to us, there's an awful lot about it that we still don't know. But most people are reasonably familiar, if they're interested in astronomy at all, with the solar cycle, which is an approximately 11-year duration cycle of activity, visible activity on the surface of the sun. It goes on producing its energy, more or less the same level, no matter what stage of the cycle we're in. But in terms of looking at it and things that can happen on the surface and how they affect the Earth, there's this 11-year cycle, which is basically a rise and fall of the amount of sunspot activity on the surface, the amount of flares that are produced, the amount of coronal mass ejections that fling plasma off into space. And when they come our way, we get an aurora and we get other nasty effects such as knockout of satellites and communications and so on. So it's highly critical. It's actually overall, in terms of the astrophysics, it's a 22-year cycle, because what happens is that every 11 years, the magnetic polarity reverses. So you get 11 years with the North Pole at the north, shall we say. The activity builds up in the middle of that cycle, then decreases down to more or less zero. The magnetic pole flips, and then you get into another cycle, build up and back down again. And that whole cycle takes 22 years. Most of us are not all that concerned about the magnetic polarity, so we think of it in terms of an 11-year cycle. And we're just starting what's called cycle number 25. They started counting these cycles from 1755. That was when, more or less, when we first became aware of the fact that the amount of visible activity on the sun does go in a cycle. It was a German astronomer, Heinrich Schwabe, who came up with this. So we had a minimum, very little activity for quite a long time, 5-6 months or so, when there's very, very little visible activity on the sun. And we're now building up into cycle 25. The interesting thing is that the last 4 cycles all were on terms of decreasing amount of activity at maximum. Each of the last 4 was slightly lower in terms of total activity than the one before. And this leads us into another interesting topic, the so-called Maunder minimum, when, as far as we can tell, although the records are not complete, in the second half of the 1600s and just into the early 1700s, there was very little visible activity on the sun. Very, very few sunspots. We didn't have telescopes there that could detect other things like CMEs and so on. But as far as sunspots were concerned, there's a period of about 50, 60 years when there's very little activity. And just by coincidence, that coincides with what is termed the Little Ice Age, which affected Northwest Europe at that time. Cause and effect, we don't absolutely know. But if the sun was to go into another Maunder minimum, That's what it was called after the astronomer Maunder who first drew attention to it. There could be serious effects in terms of how it affects weather here on Earth. That's a very complicated subject. I'm not going to go into it in too much detail. There was another minor minimum, the Dalton minimum, in the early 1800s. So is this new cycle going to continue the trend of each solar cycle being one of decreasing intensity? Well, there's a new theory now. Let me check I've got it right. The Gliceberg Cycle, which indicates, according to the theory, that actually it goes in a cycle of approximately 100 years, where you get 4 decreasing maxima followed by 4 increasing maxima. So that's yet another cycle superimposed on the activity of the sun. And the interesting thing is that so far, cycle 25, the one that we're in at the moment, is building up faster and to a higher degree of intensity than originally predicted. So if that continues, it means not only that we're going to get more sunspots, more flares, more coronal mass ejections, and hopefully more nice aurorae here on the Earth, it will mean that Gliceberg cycle theory is probably correct, and the sun is just doing what it usually does. Now, not nearly as simple as that. Even though the sun is, as I say, by far our nearest star, there's a huge amount that we still don't know about it. Although we've been able to see sunspots on it for hundreds of years, it's really only the last 50 years or so that we've been able to study it intensively in other wavelengths, from radio wavelengths right up or right down, if you like, to the very, very shortest wavelengths, the highest energy ones in gamma rays. So we have spacecraft that can study it in the wavelengths that do not penetrate the Earth's atmosphere. Still a huge amount that we don't know, like the problem of the solar coronal heating is still not entirely solved. We're not going to go into that now. But the interesting thing is, certainly as far as anybody interested in looking out for aurorae or studying the sun, just for the amount of detail that you see on it, new techniques are improving all the time in terms of imaging. New big telescopes here on Earth are studying it in ever-increasing detail, but simply because it is so important to us, we need to know how it works and how it may change. So the information so far is that solar cycle 25 is looking to be at least as active as solar cycle 24. And if anybody was following sort of aurora forecasts or studying the sun, we've had actually 3 major sunspots visible on it simultaneously over the last 4 or 5 days or so, which is something that hasn't for quite a while. So the amount of activity is definitely ramping up. And just before I hand over to Nick, one very, very important thing: you never, ever should look at the sun with the naked eye. You may try and see if there's some detail on it. You almost certainly won't. But even more important, never, ever look at it with any sort of an astronomical instrument, or you will seriously damage your eyes, probably blindness. And if you try it with binoculars, you'll go blind in both eyes at once. So it's certainly not something that you should do. There are ways of studying the sun using special equipment and special techniques. Maybe we'll talk about that later. Never try it if you don't know what you're doing. If you want to find out a bit more about it, contact your local astronomy club, and they will show you how to do it, and maybe actually let you get a look through one of their special solar telescopes. Anybody that has one of the solar telescopes already knows all this. But for anybody else, if you don't know what you're doing, don't look directly at the sun. So Nick, I'm sure you would echo that.
Absolutely. Those sunspot groups, and it's active region 29, 93, and 94. Yes, they're huge. I mean, we're talking about Uranus before. These are sunspots the size of a planet. I spent years, many years observing. We'll talk about this a bit more in the look up section towards the end. But yeah, as Terry was saying, specialist telescope. So fortunate enough to own a hydrogen alpha telescope and a calcium K-line telescope and a white light solar telescope as well. So you can look at it at different wavelengths. Hydrogen alpha really came into the fore during the Skylab era. People like Gibson, etc., who were on the Skylab missions, notable kind of astronomer as well, and scientist as well as astronaut, looking at the sun really for the first time predominantly. I mean, it wasn't the first time in H alpha, but the first time across all these different spectral bands, and been able to really improve the science of our understanding of the sun. You only have to look at what the Parker Solar Probe now, which is the fastest spacecraft ever designed because of the way that it approaches the sun so closely and the velocities it can achieve. It'll be interesting to see if this new solar cycle does ramp up to the extent that you're saying, Terry, because the impact, as you alluded to at the very opening part of that statement, on satellites could be unique. If we haven't had a solar cycle of this magnitude, and if it is this what kind of 100-year ramp up, as it were, with the 22-year cycle, the 11 to 22-year cycle in between, if we are seeing a significant ramp up now, it'll be the first time in the space age, as it were, that we are seeing this level of ramp up. The impact on the tens of thousands of very small and relatively unshielded satellites in orbit, even if they're going to standby mode or some form of safe mode, could be, pardon the pun, astronomical. It could be huge. The Parker Solar Probe, for example, and some of the other observing satellites, the observing satellites tend to be at quite significant distances. Parker's really close, and it's designed to take, a lot of energy from the sun. But if you were to get a major X-class flare, and there was one, only in the last few days, yet another X-class flare, luckily these things aren't hitting us. But if we were to get, and we've talked about this before, something on the scale of the Carrington event, or something on the scale of some of the flares that we've seen, which have come off and not been directed at the Earth, aimed our way, this could be a big problem. The sunspot groups are really interesting at the moment. It is the first time, and I've observed the sun for years, and it's the first time that I've been tempted to get their kind of calcium K-line in particular telescopes out for a long time to see what's actually going on here. There's lots of really good websites if you don't want to actually look at the sun yourself, like the Big Bear Solar Observatory, the BASS French Solar Observatory, the BASS 2000 Solar Observatory, that have really great pictures every day of what's happening on the sun. And it's a good pointer if you do have those telescopes to kind of inform you as to what's going on and make a decision as to whether or not you are going to observe it safely. As you said, it's interesting. The first sunspots, I've forgotten the name of the chap, but it was around about 1,000 years ago when the sun was low in the sky and there was a very heavy mist and you could kind of see the sun through it. And the drawings, I've forgotten the name of the chap, I think it was a priest around about 1,000 years ago, was the first person to observe sunspots. So you can imagine the size they must have been, been able to see them from the surface of the Earth just with the naked eye. Interesting. I just want to quickly go back. Chris had mentioned we're talking about the launch vehicle before, and I was reading through the chat, and sorry about this, Chris. I thought you were talking about the actual launch vehicle. It's the kind of mobile crawler transporter. You're not. You're talking about the launch site. Yes, that's incredibly expensive. And unlike Musk and his kind of capture mechanism, which he's proposing for Starship, this is going to be an expensive launch tower. So you're not wrong there. Going into the chats again. Hi, ground-based space. You're here as well. Artemis. Well, yes, Artemis is it becoming a joke? I mean, it's the cost. And, before you got here, ground-based space, we were talking about the relative cost of things. The entire Decadal Survey was saying, it was in the $40 to $44 billion, even if they wanted to launch every single mission. That's still less than Musk has paid for a website in Twitter. So money is sloshing around. Definitely, and obviously with the Decadal Survey, this has got to go through congressional approval, etc. as well. So I think after what's happened with the James Webb and what's happened with Artemis, Congress are going to be cautious again. Obviously, we had the caution, back when the James Webb was under threat and the potential for that to be cancelled. And obviously, we've undergone Constellation and various other changes to get to where we are with Artemis. And a lot of the Artemis kind of drive forward came under the Trump administration, this desire to, put people back on the moon as well. So, the costs are high. There's a big argument going on as well at the moment, and Professor Sir Martin Rees is going to be at the Hay Festival, which is a big international book festival that happens in the UK. Novelists from all over the world, but he's going to be there arguing that we don't need astronauts anymore. We should just be sending robots. I'm vehemently opposed to this because I think the whole notion of exploration is one that we should pursue, but he makes quite an interesting argument. So I wouldn't say it's becoming a joke. It's just the cost and the overruns and the delays, etc. It's not good. It's not good for science and the public perception of science, especially in the throes of an economic crisis, cost of living crisis like we're undergoing now. If we hear of, Musk spending 44 billion on Twitter or whatever, or 50 billion on Twitter, whatever it was, there's arguments of world hunger and all the different things that could, potentially be stopped with that kind of money. And again, when the public hear about the cost of launching spacecraft and, it being a kind of rich man's playground, as it were, which is still considered as, a lot of the benefits of the science aren't really kind of presented to the public in a good way. So it's, there's a kind of bubble of people like myself and Terry and people who are really into space science. I know the backroom team, there's a lot of aerospace engineers, people who work on this day in, day out, who really believe in the scientific aspects of it. But a lot of the public, for them, it's, how am I going to put a meal on the table? So yes, there's better explanations, I think, and better use of how to explain science could be something that many of us need to focus on and getting that story across more and more. Anyway, our final thing is we do run out of time so quickly. What have we got to look up to, Terry? I mean, you're going to kick this off. Tell us what we can see.
Yeah, you'll come in near the end. At the moment in the evening sky, we have the innermost planet Mercury, one that an awful lot of people have never seen. It's approaching what we call greatest elongation from the sun. In other words, its greatest angular distance from the sun in the sky is coming up on the 29th of April. Fortunately, due to the way Mercury moves and the angle of illumination and its distance, it's not actually at its brightest then, but it'll still be bright enough. And interestingly, on that very date, the 29th, it passes very close to the beautiful star cluster, the Pleiades or the Seven Sisters. Now, that's going to be low down in the twilight. Is the only way we get to see Mercury in our latitude, unfortunately. But if you have a pair of binoculars or a telescope with a wide field of view, you'll be able to see Mercury in the same field as the Pleiades. And that's something that doesn't happen all that often. If you have good eyesight and you get the timing just right and the sky is exceptionally clear and transparent at the time you're looking, you'll just about see the Pleiades, the brighter ones with the naked eye. But yeah, catch Mercury. I've been observing it on and off the last week or so. As I say, it's just past its brightest, but it's now coming up to its greatest angle away from the sun, so that's a good chance to see it. And if you miss it on the 29th, when it's closest to the Pleiades, the crescent moon, the lovely growing crescent moon, will be just to the left of Mercury as we look at it in the sky on the evening of 2nd of May. Now, Mercury will be a good bit fainter then, but you still should be able to see it with the naked eye just to the right of the moon, and certainly with binoculars it should be easy. Then in the morning sky, we have Venus and Jupiter coming together for a very close conjunction. Unfortunately, they will be very low in the sky as we see them from here. In fact, I would suggest that if you lie anywhere north of Birmingham, you're basically going to need a good pair of binoculars to see them at all. You get your best view from the furthest south you are in the UK, Ireland. In fact, down on the southern tip of Devon and Cornwall would be best, because the angle that they will be relative to the horizon will be better from then. But they'll be very, very close together on the mornings of the 29th, 30th of May, or 30th of April and the 1st of May. They will be so close that they will be less than a moon diameter apart, about 2/3 of the diameter of the moon. If you have binoculars, it'll make it an awful lot easier to see them in the twilight. So you start looking basically about half an hour before local sunrise. The sky will be getting pretty bright by then, but if you have binoculars, you should be able to spot them. Certainly Venus, which is a lot brighter than Jupiter. And then just by coincidence, almost the same time, 28th of April, the International Space Station starts another series of morning passes across the sky. So depending on where you are, you might actually see the ISS passing very close to Mercury and Jupiter. So I know you're going to talk about some other aspects, but that's basically what you can see easily with the naked eye or a pair of binoculars. So over to you now, Nick.
Absolutely. What I've just done as well, the team have put in the chat the link to the BASS solar survey archive. So this has got both current images of the sun and some of the archive images, so you can dive back through any date and see how the sun's activity is evolving. If you were to click on that link and have a look at specifically the calcium H and the calcium K line, so these are in the ultraviolet end of the spectrum. So calcium K is at 393 nanometers. I typically observe both at 393 and calcium K, which is the ultraviolet end of the spectrum, and at 656.28 nanometers, which is at the hydrogen alpha end of the spectrum, using two very different telescopes with different filter sets. What you tend to see is different layers within the sun's atmosphere, and the calcium K, calcium H line are kind of deeper down. If you have a look at the calcium H line image from today, it's astonishing. They've just put the link in the chat. You only have to look at the sheer level of activity that is associated with these sunspot groups, and you look at how, as the solar activity increases, you get these kind of bands appearing, typically at higher latitudes, and then kind of moving lower and lower. The other thing to note in that calcium H line image and in the hydrogen alpha images, if you have a look at those, is the prominences around the edge. So these are kind of the fires, as it were, the fiery trees, as they were affectionately nicknamed around the sun. You look at the one on the 2 o'clock position, or the one at the kind of 7 or 8 o'clock position, those prominences are larger than the distance between the Earth and the Moon. That calcium H line image, the big kind of white region towards the 2 o'clock area, that you're looking at somewhere around about 350 to 500,000 kilometers across. So we're talking about vast, huge things here that, this gives you a kind of scale and size of the activity on the solar surface. And as I said, the sunspot groups themselves, 2993, 2994, are the size of some of the outer giant gas planets like Uranus and Neptune themselves. I've seen sunspot groups way, way bigger than Jupiter in the past. I guess you have as well, Terry. Yep. Do not look at the sun, as Terry said, unless you've got specialist equipment. You can get very simple filters, mylar filters, etc., which you can fit to the front of the telescope. Never, ever get a filter that goes on the eyepiece end of the telescope. They are, commonly you see them on eBay, they're dangerous. They just do not touch them, because essentially the energy from the sun is still being focused through your telescope or through your binoculars onto the back, and they'll just crack. And it literally takes a microsecond for you to go blind or suffer serious permanent eye damage. So don't ever do it. Always put the filters on the front of the telescope. Calcium K line, Coronado used to make one called the PST CAC. They were about £400-500 used to be. I don't know what they are now. Hydrogen alpha telescopes around about the same price. You got companies like Lunt and Coronado again make those. Various others do them as well, as either filters or full telescopes. It's an expensive hobby, but it's a lot of fun. And the great thing about solar observing is you can do it during the daytime. And what we were saying just before we came on air is that the winter time is typically great if you're really into your observing, and obviously you want your long nights and your long dark nights, etc. Round about now, if you got a telescope for Christmas, or even if you're just taking a casual interest in astronomy, it's a good time, because by the time it goes dark, it's not spectacularly late, so you're not staying up into the wee small hours of the morning, as it were. You're still getting to see some of the fantastic things. As I said, we said at the last show, it's really good for galaxies right now. You've got the whole Virgo cluster, Markarian's chain, etc. If you've got a telescope, great to see, great to observe. There's a supernova as well up near M60, Messier 60, which again, fantastic to observe if you're looking in the right direction, if you've got the right equipment. But even if you don't have, because of the increase in solar activity, you've got an increased chance of seeing aurora, even as far south as the south of England. We've seen auroral activity over the past, past few weeks, months. And this increase in solar activity, if you were to get into solar telescopes, obviously with a white light, a simple filter telescope, all you're going to see is the sunspots. And I say all you're going to see, they're still really interesting and fascinating. You're not going to see the kind of prominences, flares, etc. around the edge. You're not going to see the level of detail that you're seeing in some of those links that we've put into the chat there. But again, it's wonderful to watch this in real time. You've got the Soho observatories, you've got a whole range of space-based observatories which is delivering images pretty close to real time all the time. So even if you don't have a telescope or don't have the right equipment, you can observe the sun and monitor it over a period of days and weeks. And especially if you've got kids, getting kids involved and being able to show them how the sun's activity is changing and what's happening on an hour-by-hour basis. And going back to Twitter, we were talking about Musk before, people are really good in terms of posting images or live views using their their equipment on Twitter, so you can follow prominences evolving. And if you were to look at, say, some of the prominences in that image that I put in the chat around the edge, they change over a matter of minutes. So you can see, it's almost like rain coming down onto the surface of the sun, where the sun's immense gravity is pulling this plasma, which is being ejected from the solar surface back down onto itself, and you get these kind of rotating filaments. It's absolutely amazing. And then occasionally you'll see a coronal mass ejection, where you've got something literally the size of the distance between the Earth and the Moon plus jetting out from the sun, and just pray it's not coming our way, as it were. But those are some of the things. The other one to do, if you're interested, and a big one that's picked up at the moment, is the UK Meteor Camera Network. So the UK Fireball Alliance have had a lot of success of late in terms of detecting potential fall sites for meteorites. There's one, obviously last year we had a famous one in Gloucestershire, but recently we've had one in Shrewsbury, in the kind of North Midlands of the UK, where, again, the UK Fireball Alliance, because of people having very simple cameras connected up to simple computers like Raspberry Pis, detecting the incoming track, as it were, of a large-scale bolide, a meteorite, in effect, potentially breaking up and hitting the Earth. And if you've got lots of cameras, you can triangulate and get an approximate location for potentially where a meteorite has fallen. And I find that really fascinating. The other thing you'll pick up with these, unfortunately, is the thousands of Starlinks and the satellites flying overhead, and potentially aircraft as well. There was Mary McIntyre, a dear friend, great observer. She's got one of these systems with her husband, Mark, and they've been picking up hundreds of satellite trails, and it's becoming a real problem when it comes to detecting, the more esoteric things like meteor strikes and, even, your average shooting star. But it's two things that you can do if you wanted to really get into science and supporting science, and not just taking pretty pictures. These are two really great things, and you can do it with your kids. It's one of those wonderful things. You set up a camera on a shed roof or whatever, just let it run overnight. Come in the next morning, the software, automated software, most of it's free. You can use that to pick up fantastic meteor trails, even satellite tracks, etc. Maybe get your pictures posted, and maybe even put in magazines. So it's well worth doing. And on that note, I think that's pretty much it for the next 2 weeks. I'll hand you back to our wonderful hosting team at Space Store. Don't forget, please support Space Store. Great bunch of guys and ladies doing fantastic work. Lots of outreach, because everything's opened up again now. Definitely worth a visit if you're down in Didcot. They've got loads of shows and loads of really interesting stuff coming up. I'll let them tell you about that. But any final words, Terry?
No, just echo everything you say there. The whole era of amateur astronomy used to sort of die whenever much more became available in terms of observing from space, for example, and close-ups of Jupiter, which is something I used to observe regularly. And now basically what I can do with my telescope is a waste of time. But the things that you say, like, for example, the Meteor Network, is very, very much worth doing. And some serious amateur astronomers with good equipment are also detecting supernovae and so on. So there's a lot that you can do, real valuable science. But don't forget, just enjoy the sky, which is what I love doing more than anything.
Absolutely.
Awesome. Thank you so much, guys, for another great show. And thanks for everyone who's tuned in tonight. I hope you guys have enjoyed it. I've saw there's been wonderful conversations and questions coming in on the chat. So thanks for all of your support. And Nick and Terry, you've done an absolutely amazing job keeping Space Store Live going over the past almost 2 years now. So thanks so much for your guys' support.
Oh, yeah, absolutely. And just again, going back to the chat, massive thank you. Yeah, remember Crew Launch 4 tomorrow at 8:52. Thanks, Chris, for that. Yes, I'm a big advocate of the coffee. Yes, you've grabbed the coffee. Oh, they are brilliant. Yes, absolutely. Coffee is my fuel, although it's not at the moment because my sore throat. I'm drinking more tea, which is, don't tell anyone. I'm drinking tea. It's like almost against my religion. But yeah, see you in 2 weeks. Huge thank you as ever for everyone who's there.
Quick request
yeah.
from me before everyone signs off. We've been working, Space Store's been working really hard with one of our new partners, Precept Tech, who are working on a new project called SatSim. I'm just going to post a link in the chat. Hopefully you guys can see that. So head over to satsim.space, try out the new demo of the virtual space lab they've got, and do the quick survey. It only takes about a minute, and we'll enter you into a prize draw to win your very own Lego Saturn V model.
Doing it.
Check it out. Share it with your friends. Check it with share it with all of your space enthusiasts, your colleagues, and yeah, it's good fun. Go check it out.
Well, don't share it with anyone if you want to win a Saturn V Lego, because they're the coolest thing ever.
Awesome.
But yeah, brilliant. Nice one.
We'll see you guys again in a couple of weeks.
Bye, folks.
Bye all.
Take care.
Cheers.
Bye.
Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Moseley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the Space Store.